The solar system is our cosmic home, a small patch of the galaxy where 8 planets orbit around an ordinary star, the Sunday. But there's something curious about the way these planets move. They all follow orbits that are more or less aligned within the same plane, and that didn't happen by accident. This alignment was inherited from the primordial cloud of gas and dust that gave birth to the Sun and the planets billions of years ago. The result is something we can picture as an orbital disk, a flat plane where the planets circle like cars on a giant racetrack. This plane roughly follows the line of the Sun's equator, but not everything is perfectly aligned. Each planet has its own slight tilt compared to that plane. Mercury, for example, is tilted about 7 degrees. Pluto, now considered a dwarf planet, has an even more tilted orbit, nearly 17 degrees. And what about comets? They don't seem to care much about the ecliptic plane. Many of them come from very distant regions and travel along orbits so tilted that they cut across the solar system almost perpendicularly, like needles piercing a vinyl record. But if the planets orbit within this disk, what lies above and below it? That's a fascinating question, and the answer forces us to rethink even our most basic ideas of direction. Here on Earth, we know what up and down mean. The ground is under our feet. The sky is above our heads. That makes sense because Earth's gravity always pulls us toward the planet's center, clearly defining what's high and what's low. But in space, that logic doesn't apply. There is no fixed floor. There's no universal north or absolute sky. An astronaut floating in orbit might be upside down compared to another, but neither of them is wrong. It all depends on perspective. A galaxy might appear upright to one observer and completely tilted to another. So when we talk about what's above or below the solar system, we're using a reference based on the plane of planetary orbits, known as the ecliptic. It's as if we take that orbital disk and use it as a guide to imagine direction in a space that, in practice, has no fixed orientation. Following this idea, we can start to explore what's above and below this plane. And what we find there is surprising. Right near the orbital plane is what we call the Oort Cloud, one of the most mysterious structures in our system. It's not a flat disk like the planetary orbits, but rather a massive spherical bubble. Scientists believe this cloud surrounds the entire solar system and stretches up to a quarter of the way toward the closest star, Proxima Centauri. That's about 50,000 to 100,000 astronomical units, tens of thousands of times the distance from Earth to the Sunday. This cloud is made of trillions of small frozen bodies, mostly composed of water ice, ammonia, and methane. They're leftover building blocks from the formation of the solar system. Early on, gravitational interactions with the gas giants like Jupiter and Saturn flung these icy chunks far away. Some escaped entirely, but others got stuck in huge orbits, which now make up the Oort Cloud. What's most fascinating is that it surrounds us in every direction, like an invisible bubble floating in deep space. But the Oort Cloud isn't something we've seen directly. It's more of a theoretical model supported by indirect evidence. For example, many long-period comets, those that take thousands or even millions of years to return, seem to come from far beyond the known planets. Their orbit suggests they originated from a region that isn't flat like the Kuiper Belt, but more spherical, indicating they come from all directions. That fits the Oort Cloud model. Above and below the planetary plane, we also find another important structure, the heliosphere. This is a huge bubble created by the solar wind, a constant stream of charged particles released by the Sunday. As these particles travel outward, they push against particles from interstellar space, creating a kind of protective shield around the entire solar system. The shape of the heliosphere isn't perfectly round. It's more like a distorted teardrop, compressed on one side and stretched out on the other due to the movement of the solar system through the galaxy. Think of it like a boat moving through water. A wave forms in front, and a trail follows behind. In this case, the solar wind pushes outward in all directions, but the pressure from the interstellar medium, the gas and dust that fill the galaxy, causes this bubble to change shape. The boundary where the solar wind slows down and starts interacting with this interstellar medium is called the heliopause. Beyond that lies interstellar space itself, the vast, cold, and mostly empty space between stars. But even there, we're not exactly alone. Surrounding the solar system is what's known as the local interstellar cloud. It's a region of slightly denser gas and dust that the sun is currently passing through. In fact, we're not just moving, we're speeding. The sun is traveling at about 828,000 kilometers per hour around the center of the Milky Way. As we do this, we pass through different regions of the galaxy. Some denser, some more rarefied. The local cloud is just one stop along the way. This means that even in deep space, far above or below the plane of the planets, the solar system is not floating in a complete void. There's structure, there's motion, and there's interaction with the rest of the galaxy. And if we go even further, we reach one of the most mysterious features of all, the local bubble. This is a vast region of space, about 300 light-years across, that's unusually empty. It's like a cosmic void where the density of matter is much lower than average. Astronomers believe it was carved out by a series of supernova explosions that happened millions of years ago. These blasts pushed away the gas and dust in the area, leaving a vast cavity that the solar system just happens to be traveling through. Interestingly, the local bubble has walls, denser regions at the edges where gas and dust have piled up. It's like our solar system is inside a giant interstellar room surrounded by cosmic walls, and beyond those walls has more clouds, more bubbles, and more mysteries. All of this helps us understand one key thing. The solar system isn't just a collection of planets orbiting the Sun. It's part of a much bigger and more complex structure that stretches in every direction, vertically, horizontally, and far beyond anything visible to the naked eye. When we look at images of the solar system in books or online, we usually see the planets lined up neatly like marbles on a table. It gives the impression that everything is flat, organized, and isolated from the rest of the universe. But in reality, things are far messier and far more dynamic. Above and below the plane of the planets, we're surrounded by distant icy bodies, interstellar gas clouds, solar winds, and bubbles carved by ancient explosions. The solar system moves through space like a ship in the ocean, creating ripples, bumping into cosmic currents, and drifting through regions shaped by events that happened long before humans even existed. And this vertical structure, this idea of above and below, helps scientists map our place in the galaxy. For example, by studying how stars and gas move relative to the galactic plane, astronomers can trace the history of star formation, supernovae, and the distribution of dark matter in the Milky Way. In fact, the Milky Way itself isn't a perfectly flat disk either. It has a central bulge, spiral arms, and even a warped structure that causes the outer edges to curve slightly. Around the galaxy is the galactic halo, a roughly spherical region that contains older stars, star clusters, and possibly large amounts of dark matter. This halo extends far above and below the main disk of the galaxy, showing once again that up and down are only meaningful if we agree on a reference point. So, next time you picture the solar system, try not to see it as a flat chart on a classroom wall. Instead, imagine it as a living, moving structure surrounded by layers upon layers of cosmic material stretching upward and downward into the unknown. We're not just orbiting the Sunday, we're part of a galactic ballet, spinning, drifting, and exploring a universe where every direction holds something new to discover. And perhaps the most amazing thing is that despite the vastness and complexity of all these layers above and below us, life managed to emerge on a tiny blue dot, a fragile oasis in the middle of all this cosmic chaos. That fact alone makes our place in the universe something truly extraordinary. Oh, now that you know what's really above and below our solar system, what surprised you the most? Was it the massive Oort Cloud surrounding us like an invisible bubble? Or the strange local bubble shaped by ancient supernovae? If this new perspective changed the way you see the night sky, leave a comment sharing your thoughts. If you enjoyed this cosmic journey, don't forget to hit the like button. It really helps the channel keep bringing this kind of content. And if you're not subscribed yet, go ahead and click that button below. There's a lot of amazing stuff coming soon. Share this video with that friend of yours who's obsessed with space. Thanks for watching. See you on the next space exploration.